Hi everyone, welcome back. In this course, we are going to learn Java streams, one of most powerful and modern features in Java. If you have ever written loops to process collections, filter data, or transform values, then this course is going to completely change the way you write code. Because with streams, we don't just write code. We write cleaner, more readable, and more expressive logic. In this course, you will learn how to process data in a functional style using streams. We will start from the basics and then gradually move towards advanced concepts. We will take 20 plus practical examples and solve real problems step by step. Let's start with Introduction to Java Streams. Well, Java Streams were introduced in Java 8 to support the functional style programming in Java. Well, what is stream? A stream is a sequence of data elements for processing. Well, we can use stream to process the data, like we can use stream to filter the data, map the data, sort the data, and reduce the collection of data. Okay, so stream allows you to perform data processing operations such as filtering, mapping, and reducing on a collection of data. Well, probably you already heard about the collections, right? So collections we use to store the data, but stream we use to process the data. So we don't use stream to store the data. Okay, so we simply use stream to process the data, like filtering, mapping, sorting, reducing, etc. Streams can be used with various data sources including arrays, collections, and even files. Well, if you look at the diagram over here, so this diagram basically summarizes the end-to-end stream pipeline. So basically we create a stream object from the sources like array or collection or IO channel. Once we create a stream object from the source, next we can perform the intermediate operations on a stream like filtering, sorting, type conversion, mapping, etc. As the intermediate operations return another stream as a result, they can be chained together to form a pipeline of operations. So why should we use streams? Well, there are two main reasons. First, streams makes your code much simpler and easier to read. Instead of writing long loops or if statements, streams let you use few simple methods to achieve the same result. Second, streams allows you to process large amounts of data efficiently. They are built to work with big data sets, which is important if you are dealing with large lists or databases. Now let us talk about how streams are different from collections like list or set. You might be familiar with collections in Java like array list or hash set, etc. Collections are used to store and manage the data. But streams are different. They don't store data themselves. Instead, streams are used to process the data like filtering, mapping, sorting, etc. Streams let you work with data that's already inside the collection without modifying the original data. Next, one more key difference is collections can be reused. On the other hand, streams are one-time use. Well, when you work with collections, you can go through the data as many times as you want. But with streams, once you process the stream data, the stream is consumed. If you need to work with the data again, you will have to create a new stream. Okay? Another important difference is how data is processed. Collections use eager loading, which means all data is stored in memory at once. But streams use lazy loading, only processing data as needed. This helps improve performance, especially with large data sets. Next, collections are imperative style. On the other hand, streams supports functional style. Well, streams supports functional style operation. This means you can easily apply transformations, filters, and aggregation to the data. Instead of writing loops or if statements, you can chain the methods like map or filter to achieve the same result with fewer lines of code. Lastly, collections are designed for data management, allowing you to add, remove, or update the elements directly. On the other hand, streams don't allow any direct modification. They are specifically designed for data processing. Your original collection stays unchanged, which helps keep data handling simpler and error-free. Alright, so these are the key differences between streams and collections. Collections are perfect for storing and managing data, while streams are designed for efficient and functional style data processing without modifying the original collection. Alright, so we'll understand these differences in depth going forward. Okay, great. Now let us talk about some key features of streams that make them powerful. First, streams are not data structures. As I mentioned earlier, they don't hold data. They just allow you to work with data that's in the collections. Second, streams are lazy. This means streams don't do any work until you tell them to. You can think of it like setting up a recipe, but actual cooking does not start until you give the final command. Third, streams are read-only. This means streams don't change the data they are processing. Instead, they create a new results based on the data without modifying the original collections. So these are the key features of Java streams. So this is a quick introduction to Java streams. In next lecture, we will take a look into types of stream operations. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into types of stream operations. Well, there are basically two types of operations in a stream: intermediate operations and terminal operations. Well, streams are all about processing data, and to do that, you use two types of operations: intermediate operations and terminal operations. Let us first discuss intermediate operations. Well, the intermediate operations don't produce the final result. Instead, they set up the data for later processing. And the key thing to remember is that intermediate operations are lazy. It means they don't execute the operation until the terminal operation is called. They transform or filter the data and return the another stream. So you can able to chain multiple operations. Alright, so just remember, intermediate operations are lazy. It means they don't execute immediately. When you call the terminal operation, then only it will execute. And the intermediate operations basically return a new stream so that you can chain the method calls. Okay, in example section we will see how you can chain the method calls. Next, here are the commonly used intermediate operations like filter, map, flatMap, distinct, sorted, pick, limit, skip. So these are the commonly used intermediate operations, and in this course we will take a look into all these commonly used intermediate operations with examples. Next, let us take a look into terminal operations in a stream. Well, terminal operations that actually execute the stream pipeline. Once the terminal operation is called, the stream processes all the intermediate steps and produces the final result. The terminal operations can return a result like list or number, or simply perform an action like printing the elements. So here are the commonly used terminal operations list: collect, for each, reduce, count, any match, all match, none match, find first, find any. So these are the commonly used methods to perform terminal operations. And terminal operations don't return the new stream. Instead, they just return the list or a number, or just print the result to the console. Okay, and once you call the terminal operation, then only the stream processes the intermediate steps and produces the final result. Okay, next let us quickly take a look into the difference between intermediate and terminal operations. Well, the main difference between intermediate and terminal operations is that intermediate operations returns a stream as a result, and terminal operations return non-stream values like primitive or object or a collection, or maybe not return anything. Okay, next, as intermediate operations return another stream as a result, they can be chained together to form a pipeline of operations. On the other hand, terminal operations cannot be chained together because terminal operations don't return the stream. Next, as intermediate operations returns a new stream, so you can chain any number of intermediate operations. On the other hand, the terminal operations don't return the stream, so in a terminal operation you can see only one terminal operation, that too at the end. Next, the intermediate operations are lazily loaded. It means when you call the intermediate operations, they are actually not executed. They are just stored in a memory and executed when the terminal operation is called on the stream. On the other hand, terminal operations are eagerly loaded. It means the terminal operations are immediately called. And once the terminal operation is called, the stream will first execute all the intermediate operations and then produces the final result using terminal operation. Next, as the name suggests, intermediate operations does not give end result. They just transform one stream to another stream. On the other hand, terminal operations give end result. Okay, and here are the examples for intermediate operations like filter, map, distinct, sorted, limit, skip. And here are the examples for terminal operations like for each, to, array, reduce, collect, min, max, count. Okay. Hi everyone, welcome back. In this lecture, we'll see how to create a stream. Well, if you can look at the diagram over here we have steps like source, stream and result. So basically we create a stream from the different sources like list, set or map or array or file. Okay. So in this lecture, let us take a look into different ways to create a stream from different sources like list, set, map, array. Okay. So once we create a stream from the source, we can perform the data processing like we can filter, we can map, we can sort. Alright, and finally we can collect the result of this stream. Alright, so in this lecture we will just focus on creating the stream from the different sources. In next lecture onwards, we will see how we can do the filtering, mapping, sorting on a stream. Okay, so let us go to our project and let us see different ways to create a stream from different sources. So let us go to our project in IntelliJ IDEA and go to the base package over here. Right click on it, new, and then choose package. Let us give package name as streams. Within a streams package, we will keep all the stream related examples. So right click on stream package, new, and then choose Java class. Let us give class name as create stream example. Okay. Next, within this class, let's create a main method. Next, within a main method, let us go ahead and let's create a stream from different sources. Well, first we're gonna create a stream from list. So here let us first create a list as a source. So here just type list. List is a generic interface. Just pass string as a type. And let us give the reference variable name as root list and then new array list. Next, let us go ahead and add the elements. So root list dot add banana and then root list dot add mango and then root list dot add apple and then root list dot add orange. Perfect. Now we have added 4 elements to the list. Well, instead of writing these 5 lines of code, let us use arrays utility class provided as a list method to create and initialize the list in a single line. For example, so here let me comment out this. So here just use arrays utility class from java.util package. It has as list method. So this as list method basically returns the list and takes the elements. So here just pass banana, comma, mango and then apple and then orange. Next, this as list method returns a list. So let us introduce a local variable over here and let us give name as root list. So instead of writing this much of code in a single statement, we have done the job. Okay. So this is basically a source. Next, we can create a stream from this source by using stream method. For example, here we have a root list. So this is the source. And in order to create a stream from this source, we can use stream method. So notice here, stream method returns a stream. Okay. So just remember, in order to create a stream from the list, we can use stream method over here. So just call this stream method and this stream method returns stream. So here let us take the result into local variable of type stream. So stream is a generic. We have to pass the type string and let us call it as stream. Okay. So here basically we created a stream from list. List is a source. Okay, perfect. So once we got the stream, next we can perform the operations like filtering, mapping, sorting, etc. We will see how we can perform the data processing operations like filtering, mapping, sorting, reducing in upcoming lectures. So in this lecture we'll just focus on creating the stream from different sources. Next, in order to test whether the stream contains elements or not, what we can do is we can print the stream. So here just call stream object. It has a for each method, and notice here for each method takes consumer functional interface as a type, and we have to use lambda expression to implement this consumer functional interface. So just call this for each method and let us pass the lambda expression. Well, consumer functional interface takes single argument as a parameter, so here we need to pass single parameter to the lambda expression. So just say element. Next, this is the lambda symbol, and within a lambda body just put the system.out.println statement and just print the element. Okay, next the lambda body has a single statement. We can remove the open and close curly braces from here. Alright, next again notice here we are using lambda expression is just to print the element. So instead of this lambda expression we can also use the method references. So here just remove this part and here just give the method reference, that is double colon, and just remove the parameter of this println method. So this is how we can use a method reference instead of lambda expression. Next, let us run the program, and here you can see these are the elements from the stream, and you can notice the sequential order: banana, mango, apple, orange. And again if you can notice the elements in the list: banana, mango, apple, orange. Okay, so stream basically maintains the same sequential order over here. Okay, perfect. So this is how we can create a stream from a list. Similarly, let us see how to create a stream from set. Well, here arrays utility class has a as a list method to create a list, but arrays class don't have a as a set method to create a set. So we can create a set like this. So just type set and then pass string as a type, and let us give the reference variable name as root set and then new hash set, and then pass this root list over here to the constructor. So here root list. So here we have converted this list into set. Now set contains all these elements. Next, let us create a stream from this set. So here just call root set. It has a stream method. Okay, and again notice here stream returns a stream of type string. Okay, so in order to create a stream from the set we can use this stream method. So just call this stream method, and let us take the result into a local variable of type stream. Stream is a generic, so let us pass the type string, and let us give name as stream1. Okay, next let us print the stream over here. So stream1 and then call for each method and then pass system dot out and then double colon, this is the method reference, and then call println method. Next, let us run the program over here, and here you can see the output apple, mango, orange, banana. Well, hash set does not maintain the insertion order. That's why the stream basically print the elements in the same order that hash set has. On the other hand, you can see list maintains the insertion order. That's why stream also maintains the same order. That is what you can see over here. Okay, perfect. So this is how we can use, we can create a stream from the set. Next, let us see how to create a stream from a map. So here create a stream from map. So here just type map interface as a reference type and then pass key type as a string and integer as a value type, and let us give the reference variable name as root map and then new hash map. Perfect. Next, let us add key value pairs to the map. So root map dot put method and then pass apple as a key and its count, let us say 10. So this basically putMap maintains the fruit and their count. Next, let us add few more key value pairs. Fruitmap dot put and then mango. Let us give its count as 15. Next, fruitmap dot put orange. Next, let us give its count 20. Next, fruitmap dot put, let us give key as banana and its count 5. Now we have a map. Next, let us see how to create a stream from a map. Well, here list and set has a stream method to create a stream directly, but map don't have a stream method to create a stream. So we have to call the entry set method on map, and then we call a stream method of entry set. For example, here let us create a stream from maps entry set. So basically this entry set method returns a set, and set has a stream method, right? So here let us call map, that is fruitmap, and it has entry set method. And notice here entry set method returns a set and set has a stream method. Okay, so just call this entry set and it has a stream method. And again, if you can notice the return type of stream method over here, stream method returns a stream of entries. Okay, so let us call the stream method and let us store the result of this stream method into a local variable of type stream. So here just call stream. Stream is a generic, just pass the type as a entry. So here just type map. So basically the entry interface is located inside a map interface. So just call map interface first and then dot entry and then pass string comma integer as a types. Next, here let us give the name variable name as map entry stream. Now we got a stream of entries. Next, let us go ahead and let us print the elements from this stream. So for that we can use for each method. So here just call stream object, it has for each method, and then pass system dot out and then method reference, that is double colon, and then followed by the method println. Next, let us run the program, and here you can see the entries in a key value pairs. So this is how we can create a stream from a maps entry set. Next, let us see how to create a stream from a maps key set. So map has these many keys, and sometime we may have a requirement to process keys, right? So for that we can convert maps keys into stream. Okay, so here let us see how to create a stream from maps key set. Okay, so only key set, not the values. So here just call the map object, that is fruitmap. It has key set method, and notice here key set method returns set, so we can call stream method on set. So just call key set method and it has a stream method, and notice here stream method returns a stream. Alright, so let us take the result into a stream. Stream is a generic, so let us pass type as a string. Next, let us give name as map key set stream. Now we have created a stream from maps key set. Next, let us display the elements of a stream. For that we can use for each method. So here just type map key set stream. It has for each method, and then pass system dot out and then method reference and then pass println. Next, let us run the program, and here you can see the output: apple, mango, orange, banana. So these are the only keys, not the values. So this is how we can create a stream for the only map keys. Okay, next we can also create a stream from maps values only. For example, here let me write the comment: create a stream from maps values. So here just call putMap object, it has values method, and notice here values method returns collection, and collection has a stream method. Next, let us take the result into a stream. Stream is generic, so let us pass type as integer and just give the variable name as map values stream. Next, let us display the elements of this stream using for each method. So here map value stream dot for each, and then pass system dot out, and then method reference, and then call println method. Perfect. Next, let us run the program, and here you can see the output 10, 15, 25. So these are the values from the map. So this is how we can create a stream from maps values. Alright, perfect. Next, let us see how to create a stream from an array. So here let me write the comment, create a stream from an array. So let us create a array of type string. So here string array, and let's call it as string array, and let us initialize the array. Just pass the fruit name banana, and then mango, and then apple. Alright, now we have an array. Next, let us see how to create a stream from this array. So this array is basically a source for the stream. So here just call arrays utility class. So make sure that you import arrays utility class from java.util package. It has a stream method, and notice here there are a lot of overloaded stream methods. So here we are going to choose first one. It takes an array. So just call this stream method and then pass array string array. Okay, next this stream method returns a stream. So let us take the result into a stream over here. Stream is generic, just pass string as a type, and let us call it as array stream. Now we have created stream from the array. So here let me write the comment, create stream from array. Next, let us display the elements of this stream by using for each method. So here array stream, and then call for each method, and then pass system dot out, and then method reference, and then println. Next, let us run the program, and here you can see the output banana, mango, apple, banana, mango, apple, and again stream maintained the sequential order over here. Okay, so this is how we can create a stream from an array. Next, stream provides op method to create a stream from individual values directly without needing of a collection or an array. So here let me show you how to do it. So create a stream using stream.op method. So this method is pretty useful to create a stream with fewer elements without needing a collection or array. So here just type stream. Stream has a op method, and we can pass the values directly to the op method. For instance, apple, and then banana, and then mango. Alright, next this op method returns stream. So here let us introduce local variable of type stream, and then pass string as a type, and let us give the name as of stream. Next, let us display the elements of the stream by using for each method. So op stream dot for each method, and then pass system dot out println. Next, let us run the program, and here you can see the elements apple, banana, mango. So this approach is useful when you have a fewer number of entries, and you can directly use this op method to add the individual values directly without needing the collection or array. Alright, so these are different ways to create a stream from different sources like list, set, map, array. Okay, great. In next lecture we will learn more about stream. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us discuss stream provided map method. Well, map method is one of the widely used method in a stream API. The map method is used to apply a function to each element in the stream and return a new stream with the transformed data. Well, basically we use a map method to transform the data in a stream. Well, in example section we will see how we can use a map method to transform each element in the stream. The map method is an intermediate operation in Java stream. As map method returns a new stream, so we can change the method calls. For example, here list of strings is a list, and we can use stream method to convert a list into stream, and we can use a map method on a stream, and again map method returns a new stream, so we can call the collect method. So this is how we can change the method calls. Okay, so map is an intermediate operation and it returns a new stream, so we can change the method calls. Okay, next, map method is commonly used to convert the objects or transform the objects, modify the data, or extract the specific fields from the complex objects. Well, in example section we will see how to use map method to convert the objects or modify the data or extract specific fields from the complex objects. Let's understand more about map method with this diagram. Well, in order to create a stream, we need a source. A source can be a list, set, map, or array. Once we create a stream, next we can call its map method. Map method takes function as a functional interface. So this function is a functional interface. It represents a function that takes an argument of type t and produces a result of type r. So basically this function we use to transform one object into another object. Okay, so in example section we will see how we can use map method to transform or convert one object into another object. Next, this function is a functional interface and we can use lambda expression to implement the functional interface. Next, the map method is an intermediate operation. It means map method returns a new stream with a transformed data. So map method returns a new stream, so we can change the method calls. Okay, next, the map method is an intermediate operation and it won't immediately execute. Once we call the terminal operation, then the intermediate operations will be triggered. Next, let us understand more about map method with examples. So let us head over to IntelliJ IDEA. Let's go to our project. And notice here, I have changed the theme from dark to light. Earlier, I was using the dark theme. For example, go to preferences, go to appearances, and here earlier I was using dark, but this dark was not looking that much of good, so I have changed from dark to light. So in order to change the theme, go to the IntelliJ IDEA, go to the preferences, go to the appearance, and here just change the theme. So here change the light and click on OK. So the light theme looks good in IntelliJ IDEA, so going forward I will be using light theme. Okay, let's go back to the map method examples. So here go to the stream package, right click on it, new, and then choose package. Let's give package name as map. So within a map package we will keep all the map related examples. So within a map package, right click on it, new, and then choose Java class. Let us give class name as stream map example. Okay, perfect. Next, let me expand it. So within this class, let's create a main method. Within a main method, let's first create a source as a list. So here just type list and then pass string as a type, and let us give the list name as a fruits, and here arrays dot as list, and then pass elements. Let us say apple, and then banana, and then mango. Okay, now we have a source as a list. Now we have source as a list. Next, let us create a stream from this list. So here just call fruits as a list. It has stream method, so we can use stream method to create a stream from this list. Next, let us store the result of this stream method in a local variable of type stream. Stream as a generic, let us pass string as a type, and let us call it as stream. Now we have a stream. Now we have stream object. Next, let us call its map method. So here we have stream object and then it call its map method. And notice here map method takes function as a parameter. Well, this function is nothing but a functional interface, and we have to use lambda expression to implement this function interface. And again notice here this map method returns a stream. Okay, so this map method is basically intermediate operation and it returns a new stream that contains the transformed data. Alright, so just call this map method over here, and next let us pass the lambda expression that implements this function interface. So this is the lambda expression syntax. So this function interface takes a single input argument and it returns the output. So here just pass a single parameter to the lambda expression, let us say element. Okay, and here if you can notice the list over here, list contains the element of type string. Okay, so now what we'll do, we'll transform or convert each string element into uppercase. Okay, so here go to the lambda expression again. So here we have passed the element as a parameter to the lambda expression, and then go to the lambda body, and within the lambda body let's have a return statement, and then convert this element of type string into uppercase. So this element is nothing but a string. It has a to uppercase method. Okay, and again this lambda body has a single statement. We can remove open and close curly braces as well as the return statement, because Java compiler will automatically infer the return type of this lambda body. Perfect. Now we have used map method to transform or convert each string element into uppercase. Okay, so this is how we can use map method to convert or transform the data. Finally, we need to collect the result of this map method, right? So map method basically returns a new stream. So let us convert that new stream into list. For that, let us call toList method. Next, let us take the result of this list method into a local variable of type list, and let us pass string as a type, and then let's call it as list, and then put the system.println and just print the list. Okay, perfect. Next, let us run the program over here, and here you can see the output apple, banana, mango. So these elements are in uppercase. Alright, so this is how we can use map method to map or convert each element of a stream into uppercase. Next, let us understand how this map method works internally. So here, before calling this map method, let us call the pick method. So here, just call this pick method. Well, pick method we use to print each element of a stream, and this pick method is pretty useful for debugging. Like we can use pick method to print each element of a stream to the console. Alright, and notice here pick method takes consumer interface as a parameter, and we have to use the lambda expression to implement this consumer interface. So this consumer interface basically takes input argument and it don't return the result. Okay, so just call this pick method over here and then pass the lambda expression. So this consumer interface takes a single input argument, so just pass element as a parameter to the lambda expression and then followed by lambda symbol, and within a lambda body just put the system.println statement and just print this element. Next, this map method is an intermediate operation and it returns a new stream of transformed data. So let us call a pick method on this new stream. So here just call pick method and then pass the lambda expression that implements consumer interface. So here just pass element as a parameter to the lambda expression followed by lambda symbol. Within a lambda body just put the system.println statement and then print the element. Okay, so if you can notice here, this pick method will basically take each element of a stream and it will print to the console. And after calling the map method, so this map method basically convert each element into uppercase and returns a new stream. And then here again we call the pick method. So this pick method basically takes each element of this new stream that returned by the map method and print to the console. For example, if I run the program over here, and if you can notice the output over here, so this apple basically printed by this pick method. So here what I will do, I will add a string so that we can distinguish before map method, and here just pass after map method. Next, let us run the program, and here we need to give the space. So here what I will do, I will give the colon and space, and here also colon and some space. Next, let us run the program again. Now it looks good. So if you can observe the output over here, before map method you can see the element apple and you can see the list apple, banana, mango. So this pick method basically takes each element of a stream, and then this map method basically transform each element of a stream into uppercase. So this is what you can see. So this apple, which is in a uppercase, is basically printed by this pick method. So this map method basically returns a new stream that contains the uppercase elements. Okay, and this pick method here we have used to print each element of a new stream that is written by this map method, and that is what you can see here. After map method, apple, banana, mango. Alright, so this map method takes each element of a stream and transform that element and create a new stream with all the transformed data and finally return that stream. Okay, so this is how the map method works. Okay, in next lecture we will understand more about map method with examples. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we had a quick overview of map method. Next, in order to understand more about map method, let's create one more example. So here go to a map package, right click on it, new, and then choose Java class. Let us give class name as stream map example2. Next, within this class, let's quickly create a main method over here, and within this main method let's create a list of strings. So here just type list is the generic, just pass the type string, and let's give the variable name as list of strings. Next, here just call arrays utility class, it has as list method, and then pass the elements of type string. Let us say 1, 2, 3, 4, and then 5. Now what we need to do is we need to convert a list of strings into a list of integers. So here we have a list of strings. Next, we need to convert this list of strings into list of integers. So in order to do that, we can use a map method. So first we create a stream from this list, and then we call the map method on the stream, and then we use map method to convert each string into corresponding integer. So let us see how to do it. So here we have a list as a source, so let us create a stream from this source. So just type list of strings object over here, it has a stream method. So we use stream method to create a stream from this list. Next, stream method returns a stream, so we can call the map method. So just call the map method, and notice here map method takes functional interface as a parameter, and we can use lambda expression to implement this function interface. So just call this map method and pass the lambda expression. So this is the lambda syntax. This function interface takes a single input argument, so let us pass single input argument to the lambda expression. So here let us say element. Next, go to the lambda body. Within a lambda body, let us write a logic to convert this element of type string into element of type integer. So here let us have the return statement, and in order to convert the string into integer, we can use integer wrapper class. It has a static utility method that is value of, and then pass element. Next, this lambda body has a single statement. We can remove curly braces as well as the return statement from here. Okay, now we have used map method to convert an element of type string into element of type integer. Next, the map method returns a new stream, and we need to convert that new stream into list, right? For that, let's call toList method. So this toList method basically convert a stream into list. Next, let us take the result into a local variable of type list, and then pass integer as a type, and then let's call it as list. Next, let's put the system.out.println statement and just print the list. Next, let us run the program over here, and here you can see the output, list of integers. So this is how we can use map method to transform or convert a list of strings into list of integers. Hi everyone, welcome back. In this lecture, we will discuss how to filter the streams with a filter method. The filter method is used to select elements from a stream based on a condition. Well, filter method is one of the widely used method in a stream API to filter the elements from a stream based on a condition. The filter method is an intermediate operation in a Java stream. Well, intermediate operation basically, loaded lazily. It means the intermediate operation don't execute immediately. Once the terminal operation is called, then only the intermediate operation will execute. Okay, so as filter method is an intermediate operation, so filter method won't get execute immediately. Once the terminal operation is called, then only the filter method will get executed. And again, immediate operation basically returns a new stream. So filter method returns a new stream so that we can change the method calls. Filter method takes a condition, also called a predicate, and returns a new stream containing only the elements that satisfy that condition. Well, stream method basically takes a predicate. A predicate is nothing but a functional interface, and we have to provide the lambda expression to implement the predicate functional interface. Well, this diagram basically summarizes how the filter method works. So first we create a stream from the source. The source can be a collection or array. Once we create a stream, then we can filter that stream using filter method. So filter method takes predicate. Well, predicate is nothing but a functional interface that represents a condition or a test, taking one input argument and returning a Boolean result. So as we know that functional interfaces can be implemented by a lambda expression, isn't it? So basically we use a lambda expression to implement this predicate functional interface. Next, the filter method is an intermediate operation. So this filter method won't get executed immediately. It will store in memory. Next, once the terminal operation is called, then this filter method will get executed. Okay, and again this filter method is an intermediate operation, so it will return a new stream containing the elements that meets the condition. Okay, so filter method basically returns the new stream that contains the elements that satisfy this predicate condition. Okay, we will see an example how we can use the filter method to filter the elements from the stream by using the condition. Okay, next let us go ahead and let us create an example to understand more about the filter method. So let's go to our project in IntelliJ IDEA, and here go to the streams package, right click on it, new, and then choose package. Let us give package name as filter. Within a filter package we keep all the filter method related examples. Next, within a filter package, let's create a class. Let's give name as stream filtering example. Okay, next, within this class, let's create a main method. Well, within a main method, we are going to use the filter method to filter the even numbers from a list. Okay, so let us go ahead and let us first create a list as a source. So just type list and then pass integer as a type. Let us give reference variable name as numbers, and then call arrays utility class. It has as the list method, and then pass the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the list. It contains the numbers from 1 to 10. Next, so this is basically a source. Okay, well, in order to understand the filter method properly, let us first see the traditional way of filtering even numbers, and then later we will see how to use stream provided filter method to filter the even numbers. So here let us first see the traditional way of filtering even numbers from a list. So here traditional way means before Java 8. So in Java 8 stream APIs were introduced. So before Java 8, how we were filtering the even numbers from a list, that is what doing over here. So we can do it by using for each loop. So here just create a for each loop. So just pass integer and then number and then iterate over a list. Okay, next within this for each loop, let us have a if statement, and let us add a condition like number and then modulo 2 equal to 0. Well, if a remainder of this number is 0, then the number is even number. Okay, next if this condition satisfies, then we'll add a even number to the list. So in order to hold the even numbers, we have to create a one more list over here. So just create a list. So list and then integer, and let's call it as even numbers equal to new array list. Next go to the if condition and here just add the even numbers. So even number dot add and then number. Okay, perfect. Next let us print the even numbers. For that let's put the system.out.println statement and then pass even numbers. Next let us run the program and you can see the output 2, 4, 6, 8, 10. So these are the even numbers. Okay, so before Java 8 this is how we were filtering the even numbers from a list by using for loop and if statements, isn't it? Next let us go ahead and let us see how to use filter method from a stream to filter the even numbers from a list. Well, if we use the stream API, then we don't have to use the for loops or if statements. We simply use some methods to perform the operations. Okay, in our case we are going to use filter method to filter the even numbers from a list. We are not going to use any for loop or if statements. Okay, so let me show you how we can do that. So here let me write the comment using stream API to filter even numbers. Alright, so first we need to create a stream from a source. So in our case source is a list, isn't it? So here just call the list object, that is numbers. It has a stream method and notice here stream method returns a stream. Okay, so we use stream method to create a stream from the list. So just call this stream method and then here let us assign the result of this stream method to a local variable of type stream. Stream is a generic, so just pass integer as a type and let us give name as stream. Okay, now we have created a stream from a source, that is list. Next we can use stream provided filter method to filter the elements from the stream. Next here let us call the stream object. It has filter method and notice here filter method takes predicate functional interface as a parameter and we have to use the lambda expression to implement this predicate functional interface. So predicate basically represents a condition that takes one argument and returns the boolean value either true or false. Next you can notice the return type of the filter method. So filter method basically returns a new stream that contains all the elements that satisfy this predicate or a condition. Okay, so just call this filter method and then pass the lambda expression that implements this predicate functional interface. So this is the lambda expression syntax. Okay, next the predicate functional interface takes one input argument. So let us pass one parameter to the lambda expression. So let us say number. Next within a lambda body let us have the return statement and then here let us write the logic to find the even number. So here number modulo 2 equal to 0. If remainder of a number is 0 then the number is even number. Next you can see here the lambda body contains single statement, so we can remove the open and close curly braces as well as the return keyword from here. So let me remove open and close curly braces. Next, if lambda body contains a single parameter, we can remove open and close parentheses from here as well. Next, this filter method returns a stream, so we can change the method calls, right? So here after filtering the elements from a stream, we need to collect the result. For that we can call toList method. Okay, next let us take the result of this toList method into a separate variable of type list and let us give the type as integer and let us call it as even numbers. So even numbers variable is already declared, so let us give name as filtered even numbers. Okay, perfect. Next let us put the system.out.println statement and just pass this filtered even numbers over here. Next let us run the program and you can see the output 2, 4, 6, 8, 10. So this is how we can use filter method to filter the even numbers from a list. Well, notice this piece of code over here. In order to improve the readability of the code, we have written this much of code, but we can refactor this code and make it shorter. For instance, instead of assigning the result of this stream method into a separate variable, so just copy this code and replace this stream object with this code. Next, remove this line of code from here. Okay. Next, instead of assigning the result of this method calls, we can simply put this statement in a system.out.println statement. For instance, just copy this piece of code and here go to println method and just pass it. Next, let us remove this code. In a single line of code, we have filtered the even numbers from a list using filter method. Next, if we run the program, you can see the output 2, 4, 6, 8, 10. This is awesome, isn't it? So we haven't used any for loop or if statements. By simply using filter method, we have filtered the even numbers from a stream, and you can see the code. This is clean, concise and shorter, isn't it? So this is what the functional programming basically. So instead of using loop or if statements, by using couple of methods, we have successfully filtered the even numbers from a list. Okay, so in functional style programming, basically we write a clean, shorter and concise code. So that is what we are doing by using Stream API. Okay, great. In next lecture, we will learn more about filter method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have seen the usage of filter method. And we have also seen like how to filter the even numbers from a list by using filter method, isn't it? So in this lecture, what we'll do, we'll create one more example to understand more about filter method. So in previous example, we have used list of integers. In this example, we are going to use list of strings. Okay, so here let's go to filter package, right click on it, new, and then choose Java class. Let us give class name as filter string list. Okay, next within this class, let's create a main method. Within a main method, let's create a list. So here just type list and then pass string as a type, and let us give name as fruits, and then arrays dot as list, and then pass the fruits as elements. So this is basically a source for a stream. So we create a stream from a source, and in our case list is a source. Next, let us go ahead and let us filter the banana element from the list. And again, first we are going to use the traditional way, like before Java 8, how we were filtering the list of strings. So here let me write the comment, traditional way, before Java 8. Well, before Java 8, there were no Stream APIs are introduced, right? So we supposed to use the for loop and if statements to filter the elements from a list, isn't it? So here first of all, let us declare a list to hold the filtered elements. Okay, so here list of type string, and then let us give the variable name as filtered fruits, and then new array list. Next, let us use for each loop to iterate over a list. So this is the for each loop syntax, and then string fruit, and then fruits. Next, within a for each loop, let us have a if statement to add the condition. So condition is like we are going to filter the banana element from the list. For that, here just call fruit. Fruit is a string, it has equals method, and here just pass banana. So this will basically filter the banana element from the list. Next, let us have a filtered fruits list. It has add method and then pass fruit. Okay, so this is how traditionally we are using for each loop and if statement to filter the specific element from the list. Okay, next let's put the system.out.println statement and just print the filtered fruits. Next, let us run the program, and here you can see the output banana. Okay, next let us go ahead and let us see how to use Java 8 Stream API to filter the strings from a list. So here using Java 8 Stream API to filter strings from a list. So here list is basically a source. So from a list we can create a stream. Okay, so here just call the list, that is fruits. It has a stream method, and stream method returns a stream. So just call this stream method, and let us take the result into a local variable of type stream. Stream is a generic, so let us first string as a type and let us call it as stream. Perfect. Now we have created a stream from list. Okay. Next we can use filter method to perform filtering operation on this stream. Okay, so here just call stream. It has filter method, and filter method takes predicate functional interface as a parameter, and we have to use lambda expression to implement this predicate functional interface. So predicate is nothing but a condition that takes one argument and returns either true or false. Okay, so basically we are going to add a condition within this filter method, and again notice here filter method returns a stream. Okay, so that we can change the method calls. So just call this filter method and let's add a condition using lambda expression. So here this is the lambda expression syntax. So predicate functional interface takes single parameter as a argument, so we have to pass single parameter to the lambda expression. So let us say prut, and if there is a single parameter in a lambda expression, we can remove open and close parenthesis. Next, within a lambda body, let us add the condition like return and then prut dot equals banana. Next, lambda body contains single statement. We can remove open and close curly braces as well as the return keyword. So this filter method basically select all the elements that satisfy this condition and create a new stream and store those elements into that stream and just return that stream. Okay, so as this filter method returns stream, we can change the method calls. So here just call toList method. Next, let us take the result into a separate list and just pass the string as a type and let us call it as result. Next, let us put the system.out.println statement and just print the result. Next, let us run the program, and here you can see the output banana. Okay, next let us simplify this code. So here instead of assigning the result of this stream method to a separate stream object, just copy this code and just remove this stream object and just paste it and remove this line of code. Next, again instead of assigning the result of this statement to a separate variable, let us just copy this piece of code and just pass to the println statement. Okay, and just remove this line of code. Alright, so in a single line of code we have successfully filtered the strings from a list. But traditionally you can see we are writing a lot of code. Okay, so using Javaguides Stream API we can write the clean, concise and shorter code. Alright, great. In next lecture we will see the real world use case of filter method. So we are going to basically see how we can filter the products by category, and we will also see how to apply multiple filter conditions. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we will discuss the real world use case of filter method. Well, we are going to take an example of e-commerce application like the product entity. So we will see how to filter the products that belongs to a specific category, and we will also apply multiple filter conditions like how to filter the products that belongs to a specific category, as well as the product price is greater than some price. Alright, so let us go ahead and let us see how to use filter method in a real-time projects. So here go to our project again and go to filter package, right click on it, new, and then choose Java class. Let us give class name as filter custom objects. So here basically we are going to filter the product. So product is basically a custom class, that's why this is the class name. Next, within this class let's create a main method. Well, first we need to create a product class, isn't it? So here just type class and then product. Within a product class let us define the instance variables, private string product name, and then private double product price. Next, private string category. Let us keep these three fields. Next, let us quickly create a constructor. So right click on this product class and then generate, and then select constructor and select all these fields, click on OK. Next, let us also create a getters method. So right click, generate, and then getter, and then choose all these fields, click on OK. Now we have created a custom class, that is product. Next, go to the main class, go to the main method. Within a main method, let us go ahead and let's create a products and add to the list. So first we need to prepare a source to create a stream, isn't it? So we are going to use a list as a source over here. So just type list and then pass product as a type. Let us give name as products and then new array list. Next, here let us create a couple of products and add to the list. So here products dot add and then new product, and just give product name as phone, and let us give product price 999.99, and let us give category over here. So let us say electronics. Now we have added single product. Similarly, let's add a few more products. Perfect. Now we have added a couple of products to the list. Next, let us create a stream from this list. So this list is basically a source for a stream. Okay. Next, here create stream from list. So list is basically a source. So here just call the list, that is products. It has a stream method, and notice here stream method returns a new stream. So just call this stream method over here and take the result of this stream method into a separate local variable of type stream. So stream is a generic, just pass product as a parameter to it and just call it stream. Okay, perfect. Now we have a stream in place. Next we can call its filter method to filter the products. So here just call the stream object. It has filter method, and notice here filter method takes predicate functional interface as a parameter, and we have to use lambda expression to implement this predicate functional interface. And again notice here filter is an intermediate operation, so it should return the new stream. Okay, so just call this filter method. Next, let us pass the lambda expression that implements predicate functional interface. So here basically we are going to filter the products belongs to a electronics category. So here let me write the comment, filter the products that belongs to electronics. Alright, so basically we are going to add a condition to the filter method to filter the products that belongs to electronics category. Okay, so go to the filter method, and here let us construct the lambda expression that implements predicate functional interface. So here just add the lambda expression syntax first. So as predicate functional interface takes single parameter, so let us pass a single parameter to the lambda expression. So here product. So if there is a single parameter in a lambda expression, we can remove open and close parenthesis. Next, go to the lambda body, and here let us add the condition. So just have a return statement and then product dot get category. So get category returns a string. String has a equals method, just call equals and then pass the category electronics. Okay, so this is the logic to filter the products that belongs to this electronics category. Okay, next the lambda body has a single statement, so let us remove open and close curly braces as well as the return keyword from here. Alright, perfect. Next, this filter method returns a new string that contains all the elements that satisfy this condition, right? So as filter method returns new stream, we can change the method calls. So here just type toList. So here we are basically going to convert stream back into list. For that we are going to use toList method. Perfect. Next, let us take the result of this toList method into a separate variable of type list. So here just type list and then pass product as a type, and let us give the variable name as filtered products. Perfect. Next, in order to print the products, what we can do is we can call for each method. So here filtered products, so this is basically a list. It has a for each method, and notice here for each method takes consumer functional interface, and we have to use lambda expression to implement this consumer functional interface. So just call the for each method and then pass the lambda expression syntax, and consumer basically takes a single parameter, so here just pass product as a single parameter to the lambda expression, and within a lambda body just put the system.println statement and then print product. Okay, next let us create a toString method in a product class so that we can print a complete product object. So go to the product class, and here at the end just generate a toString method. So right click, generate, and then toString, select all these fields, click on OK. Next go back to our logic over here, go to for each method, go to system.println, and here product.toString. Perfect. Next let us run the program, and there we go, you can see the output over here. So all these products are belongs to electronics category. So this is how we can use Stream API provided filter method to filter the products that belongs to a specific category, that is electronics. Okay, so in real-time project basically we use a filter method a lot. Okay, and this is the example to demonstrate the real world example. Next let us go ahead and let us see how to apply multiple filter conditions. Well, we can apply multiple conditions within a single filter method, or we can use multiple filter methods to apply multiple conditions. For example, in this filter method we have a single condition, but we can also add a multiple conditions by using logical operators. For example, here logical AND operator, and then product dot get price greater than 1000. So this is how we can add a multiple conditions using single filter method. But let us see how to use multiple filter methods to apply multiple filter conditions. Okay, so here let me undo it and let me keep a single conditions within this filter method, and here let us see how to chain multiple filter methods. Okay, so here applying multiple filter conditions. Alright, so these are the two conditions. Okay, the first condition is product must belongs to electronics category, and second condition product price must be greater than 500. So here we have already written a logic, so we can simply copy this piece of code and we can paste it over here. Okay, here let me comment out this code for time being. Next here we have applied the single condition, that is product must belongs to electronics category. Next let us apply one more condition, that is product price must be greater than 500. So in order to apply the second condition we are going to use one more filter method. As filter method returns a new stream, we can change the method calls, isn't it? So here go at the end and then call filter method over here and add the second condition. So this filter method takes predicate functional interface, and we have to pass the lambda expression. Okay, so here product and then product dot get price greater than 500. That's it. So this is the condition to filter the products whose price is greater than 500. Okay, next let us run the program and let us see the output. Well, notice here there are three products, and if you can notice the price and category. So these three products belongs to electronics category, and these three products price is greater than 500. You can see 999, 1499, 1299. If I give here the price 1000, then this should return the two products, because you can see in a list you can see the TV product has a price 1499 and laptop has a price 1299, and these two belongs to our electronics category. Okay, so this logic will basically filter these two products. If I run the program, you can see the output over here. So TV product is belongs to electronics category and has a price greater than 1000. Laptop product is belongs to electronics category and has a product greater than 1000. So this is how we can apply multiple conditions by using Stream API filter method. So in real-time project, basically we use a filter method lot to apply single or multiple conditions. So that is what I have demonstrated over here. Okay, so this is the real world example to use a Stream API filter method. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us write a Java program to convert a list of string to uppercase and lowercase using Javaguides stream. Well, here is a given input list of strings and we need to convert this list of string to uppercase and lowercase using Javaguides stream. Okay, so let us see how to do it. So first we'll convert this list of string to uppercase and then later we'll see how to convert the same into lowercase. So here just call the list, that is words. It has a stream method. So this stream method creates a stream from this list. Next, stream has a map method. So we use this map method to map the string into uppercase. And notice here map method takes functional interface as a parameter and we have to use lambda expression to implement this functional interface. So just call this map method. So here just pass the lambda expression. So let us give string as a parameter to the lambda expression and then followed by lambda symbol and then lambda body. So within a lambda body, let us write the logic to convert this string into uppercase. So string has two uppercase method. So just call this two uppercase method to convert a string into uppercase. And again notice here we are using lambda expression just to call the method, right? So we can replace this lambda expression with the method reference. Even you can see the IntelliJ IDEA give the tips like convert this lambda into method reference. Okay, so let me show you how we can replace this lambda expression with method reference. So just call the string and then double colon and then call its method, that is to uppercase. That's it. And finally let us collect the result by using toList method. And notice here toList method returns list of string. So just call toList method and let us take the result into a local variable of type list and then string and let us call it as result. Next put the system.out.println statement and then print the result. Next let us run the program over here and you can see the output. All the strings in a list are converted into uppercase. Similarly, let us go ahead and convert the list of strings into lowercase using Javaguides stream. The logic is same, but we need to just call two lowercase method on this string. Okay, so here let me copy and comment out this code and here let me paste it, and here instead of two uppercase just call two lowercase. That's it. Next let us run the program and you can see the output. All the list of strings are converted into a lowercase. Alright, so this is how we can use Javaguides stream to convert a list of string into uppercase and lowercase. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will discuss how to find the average of a given list using Javaguides stream. Well, here is a given list of integers and we need to find the average of this given list of integers using Javaguides stream. Alright, so let us see how to do it. So first of all, we need to convert this list into stream by using stream method. So here just call the list, that is numbers. It has a stream method. So this stream method basically create a stream from this list. And if you can notice the return type of this stream method, stream of integers. And notice here stream is a generic, it has a integer as a wrapper class, right? So just call this stream method. Next, in order to use the average method on this stream, we first need to convert this integer wrapper class into the primitive int type. Then only we can able to apply the average method. Okay, so in order to convert the wrapper integer class object into the primitive type int, we can call map to int method. So just call this map to int method, and again notice here map to int method takes two int function as a parameter and we have to use the lambda expression to implement this to int function interface. So just call map to int let us pass the lambda expression. So here num object is nothing but a integer wrapper class object. Next, followed by the lambda symbol, and then this num integer wrapper class object has int value method. So this int value method basically returns the primitive int type. So you can see the return type int. Okay, perfect. Now we have mapped the integer wrapper class object into the primitive int type. Next, we can able to call the average method over here. And again notice here average method returns optional double. So in order to get the double value from the optional double, we can call get as double method. And notice here get as double method returns a double primitive type. So just call this method. Next, let us store the result of this method into a local variable of type double, and let us call it as average. Perfect. Next, let's put the system.out.println statement and just print the average. Next, let us run the program and we can see the output over here 30. Okay, so the average of this list of integers is 30. Alright, it's pretty simple. So what we have done, we have first converted the list into stream first, and then we have converted the integer wrapper object into primitive type int, and then we have called the average method to calculate the average. Next, we have called get as double method to get the average in a double. So the average can be a decimal value, that's why here we are using double. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us write a Java program to find the square of a first three even numbers using Javaguides stream. Well, here is a given input list of numbers and we need to find the square of first three even numbers using Javaguides stream. So in this list you can see the even numbers 2, 4, 6, 8, 10, and we need to find the square of first three even numbers like 2, 4 and 6. Okay, so let us see how to do it. So first of all we need to convert this list into stream. So here just call numbers is a list, it has a stream method to create a stream from this list. Next, stream has a filter method. So first we need to filter the even numbers from the list, right? So here just call the filter method, and notice here filter method takes predicate functional interface as a parameter, and we have to use lambda expression to implement this predicate interface. So just pass the lambda expression. So let us give the parameter to the lambda expression. So let us say n, and then within a lambda body just add the condition to filter the even numbers. So here n modulo 2 equal to 0. If remainder is 0, then the number is even number. So this filter method filters all the even numbers from the stream, but we need the first three even numbers to find the square, isn't it? So for that, what we can do is we can use the limit method and we can pass the value 3. So this will restrict the stream to get the first three even numbers. Okay, so here we are using limit method to limit the stream. Okay, so this limit method limit to the first three even numbers. Next, let us use map method to find the square of first three even numbers. So just call the map method over here, and notice here map method takes function interface as a parameter, and again we have to use lambda expression to implement this function interface. So here just pass n as a parameter to the lambda expression followed by lambda symbol, and within lambda body just write the logic to find the square. So here n into n. Finally we need to collect the result. For that let's call the collect method and then pass collectors dot toList method. So instead of using this we can also use the toList method. Okay, so this toList method basically convert the stream of elements back into list. Next, let us take the result into a local variable of type list and then pass type integer, and let's call it as result. Perfect. Next, let's put the system.out.println statement and just print the result. Next, let us run the program over here and here you can see the output. This is the square of first 3 even numbers. So 2 is the even number, first even number, and you can see its square 4. Next 4 is the second even number and you can see its square 16. 6 is the third even number and you can see its square 36. Okay, perfect. So what we have done here, we have converted a list into stream by using stream method, and then we have used a filter method to filter all the even numbers, and then we have limited to the first 3 even numbers by using limit method, and then we have used a map method with this logic to find square of each number, and then we have called toList method to collect the result back into list. Okay, this is it. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us discuss one more real world example of collect method. Well, we'll basically see how to group the products by category. Well, a common use case of collect method is to group data by certain attributes. So let us group products by their category using collectors.groupBy method. Okay, so in order to demonstrate that, let's create a new class. So go to collect package, right click on it, new, and then choose Java class. Let us give class name as grouping products example. Next, within this class, let's create a main method. Well, we are going to group the products, so here just create a product class. So just type class and then product. Within a product class, let us define the instance variables private string name and then private string category. To keep it simple, let us have these two fields in a product class. Next, let's create a constructor. Right click, generate constructor, and select these fields, click on OK. Next, let us also create a getter setter methods. Right click, generate getter and setter, choose these two fields, click on OK. Perfect. Now we have a product class. Next, let's go to the main method. Within the main method, let's create a list of products. So here just type list and then pass product as a type, and let's give reference variable name as products. Next, let us use arrays dot as a list method to create a list, and here let us pass products to the list. So here new product and then pass product name as laptop, and let's give product category as electronics. Similarly, let's add a few more products. So here new product and then product name, let's give shirt, product category clothing. Next, new product, let's give product name as phone and product category electronics. Next, new product and then product name, let's give jeans and then product category clothing. Perfect. Now we have a list of products. Next, let us create a stream from this list. So here just type products. It has a stream method. So we use stream method to create a stream from this list. Next, let us take the result of this stream method into a local variable of type stream. Stream as a generic, just pass product as a type, and let's give variable name as stream. Okay, now we created a stream from this list. Next, we can call the stream related methods by using this stream object. So here just call stream object. It has a collect method. So here basically we are going to group the products by category, right? For that, call the collect method. Next, let us pass the collectors utility class. This collectors utility class has a grouping by method, and notice here this group by method takes two parameters and returns a map. Okay, so this grouping by method is pretty useful to group the elements in a stream based on the criteria. This group by method works like a group by clause in a SQL statement that allows you to classify the elements of a stream into groups and collect the result in a map. Okay, just call this group by method over here, and here just pass the name, that is product dot get category. So here basically we are using method reference to just call the get category method of this product. Okay, That's it. Next, this group by method returns a map. So let us take the result of this group by method into a local variable of type map, and here just pass string as a key type, list as a value type, list as a generic, let us pass product as a type, and here let us give the variable name as map. Well, notice the map structure over here. So here we group the products by category, right? So here map basically contains key value. So this key basically contains a category and value basically contains products. So one category can have multiple products, isn't it? That's why you can see the map structure. This group by method basically group the products by category and it returns a map. The map contains key as a category and value as a product. So one category can have many products. Okay. Next, let us put the system.out.println statement and just print the map. Next, let us run the program over here and you can see the output. Clothing is a category and followed by the products. There are two products. If you can notice the list, so clothing category has two products, shirt and jeans. That is what you can see. So in order to print this properly, let us create a toString method in a product class. So go to the product class, go at the end, and here right click, generate, and then toString, select these fields, click on OK. Perfect. Next, let us rerun the program, and now you can able to see here clothing is a category. So this category has two products, shirt and jeans. Next, electronics category, it has two products, laptop and phone. So this is how we can use collect method along with collectors.grouping by method to group the products by category. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us write a Java 8 program to find the age of a person if the birthday date has given. So here we have a Java project. So within that, let's create a Java program. So here just create a new class over here and let us give class name as calculate age, and within this class let's create a main method. Well, the execution of the Java program starts from main method. So let us have a main method over here. Within this main method, let's create a scanner class object to read the input from the user. So here let me write the comment, creating a scanner object to read the user input. Well, basically we create a scanner class object to read the user input, and after using it we close the scanner class object by using close method, right? So basically we have a try with resource statement that will automatically close the scanner class object after using it. Alright, so here let us use try with resource statement to automatically close the scanner class object. So this is the syntax for try with resource statement, and here within a parenthesis just create an instance of scanner class. So scanner equal to new scanner and then pass system dot in as a parameter to the constructor. Next, within a try block, let us use scanner class object to read the user input. Well, before that we need to prompt the message to the user to enter the birthday date, right? So for that, let's put the system.out.println. So here is a shortcut, just type SOUT and hit enter. This will give system.out.println in an IntelliJ IDEA. Next, here just add the string, enter your birthday date, and you should provide the birthday date in this format, year followed by month and then followed by date. Okay. Next, let us use scanner object. It has next line method to read the string from the user. Next, this next line method returns string. So let us take the result into local variable of type string over here and just call it as birthday date string. Now we got the birthday date in a string format. Next, let us parse this string into a local date. So here just call a local date. So this local date is a class from java.time package, and this local date class was basically introduced in Java 8. So just call this class. It has a static method parse. Okay, and notice here parse method takes a sequence of characters, that is string. So just call this parse method and then pass birthday date string. Next, this parse method returns a local date. You can see here. So here let us introduce a local date and let us give the variable name as birthday date. Okay, now we have converted a birthday date which is in a string format into a birthday date object. Next, in order to find the age of a person, we have to get the current date. So here let me write the comment, get the current date. So we can get the current date by using local date class. So just call local date class. It has a now method. So this now method returns a current local date. So just call this method and let us take the result into a local variable of type local date and let's give the variable name as current date. Okay, perfect. Now we got a birthday date as well as the current date. Next, let us find the age. So in order to find the age, we have to find the period between these two dates. So in order to do that, we can use period class. So here just call period class from java.time package. So this period class was basically introduced in Java 8 to find the difference or period between dates. So just call this period class. It has a between method and this between method takes a start date and end date. Okay, and we can find the difference between these two dates. So here just call the between method and then pass the birthday date as a first parameter and then current date as a second parameter, and this between method returns a period. Okay, so let us take the result of this between method into a local variable of type period and let's use local variable name as age. Now we got the age in a period format. Next, let us get the years from this period object. So here just put the system.out.println statement and then let us add the string UR and then followed by let us print the age in years. So just call age and it has a get years method and then followed by just print the strings years old. Okay, next let us go ahead and let's run the program, and here let us enter the birthday date. So here I am going to enter my birthday date, year, and then followed by the month and then followed by the date. Okay, so this is the format that we have to use to enter the birthday date. Next, hit enter and here you can see you are 33 years old. Okay, so this is how we can use the Java 8 provided classes to find the age of a person if the birthday date has given. Okay, next let us rerun the program again and let's find out the age of a different person. So here just enter the age 1992 and then month 0601 and hit enter. You can see you are 32 years old. Alright, so you can use this program and you can find your age by entering your birthday date. Alright, perfect. Hi everyone, welcome back. In this lecture, let us see how to find the frequency of each character in a given string using Java 8 streams. Well, here is a main class, within that a main method, and here is a given input string. Now we need to find the frequency of each character in this given string using Java 8 stream. So here first of all we need to convert this input string into stream of characters. Then only we can use the stream related methods, right? So here let us convert this input string into stream of characters. For that we can use chars method on this string object, and again notice here chars method returns int stream. Okay, so just call this chars method and let us take the result of this chars method into a local variable of type int stream and let us give local variable name as stream. So here int stream basically represents the ASCII values for each character in the stream. Next we need to convert the ASCII value into corresponding character. For that let us call stream here and then it has map to object method. So this map to object method takes int function as a parameter, and we have to use the lambda expression to implement this int function interface. Okay, and again notice here this int function we use basically to convert the ASCII value, that is integer, into the character. So here just call this map to object method and let us construct the lambda expression that implements int function interface. So here let's pass a c as a parameter to the lambda expression, followed by the lambda symbol, and within a lambda body just pass the c, and here we need to basically add the casting. Okay, perfect. Now we have mapped the ASCII value to corresponding character. Next, let us call the collect method over here. Next, we need to group by character and count the frequency. For that, here let us call collectors utility class from java.util.stream package. So this collectors class has a grouping by method. So let us call this grouping by method to group each character and their corresponding count. So here just call grouping by method. And next, grouping by method takes two parameters. So let us pass character as a post parameter. So in order to get the character from the stream, we can use function.identity method over here. Well, this identity method returns each character from the stream. Next, we need to count the frequency of each character. For that, let us call the collectors class again, and it has counting method. Okay, finally let's put the semicolon over here. Next, let us store the result into map. So here just call map and then pass types to key and value pairs. So here character is the type for key, and then long is the type for value, and let's give character long map as a variable name. And finally let's put the system.out.println statement and just print the map. Next, let us run the program over here, and you can see the output. There is a one space in the input string, that's why you can see it's count 1. Next, R count 1. Next, D count 1. And then here you can see L. So L occurs 3 times in the input string, that's why it's count 3. Next, O occurs twice in the given input string, that's why you can see O has a count 2. Alright, so this is how we can count the frequency of each character in a given string using Javaguides stream. It's pretty simple. So first we need to convert the input string into the corresponding stream of characters using chars method. And this int stream basically represents ASCII values for each character. We need to convert the ASCII value into corresponding character by using this map to object method over here. Next, this group by method groups the characters based on their identity using function.identity method. And this counting method counts the occurrences of each character in the stream. Alright, so this is the simple program to find the frequency of each character in a given string using Javaguides streams. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us see how to find the maximum number and minimum number in a list using Javaguides stream. Well, here is a given list and we need to find the maximum number and minimum number in this given list using Javaguides stream. Well, if you can closely observe the list over here, so 10 is the maximum number and 1 is the minimum number. Next, in order to use the stream methods, we have to first convert this list into stream. Okay, so here let us first convert list into stream. So just type numbers list, it has a stream method. So notice here stream method returns stream of integers. So just call this stream method and let us take the result of this stream into a local variable of type stream. Stream as a generic, so let us pass integer wrapper class over here and just call it as stream. Alright, now we have converted a list into corresponding stream. Now we got the stream object, so let us call its methods. So here just call stream object, it has map to int method. Well, if you can notice here, stream contains the integer wrapper class objects, right? But we need to have a primitive int types, right? So in order to convert the integer wrapper class into their corresponding primitive type, we have to use map to int method over here. Okay, so notice here map to int method takes to int functional interface, and we have to use the lambda expression to implement this to int function functional interface. So just call this map to int method over here. Next, let us pass the lambda expression to this method. So here just pass num as a parameter to the lambda expression. So here num means this integer wrapper class object. Okay. Next, the lambda symbol and then followed by the lambda body. So here within the lambda body, just call the integer wrapper class object, that is num, and then it has int value method. So this int value method basically convert the integer wrapper class object into their corresponding int primitive type. So just call this method. Now we have used map to int method to map the integer wrapper class object to their respective primitive int type. Next, we can call the max method to find the maximum number. So if you can see the return type of map to int method over here. So map to int method basically returns int stream. Okay. So we can call the max method on this int stream. So here dot max, and notice here max method returns optional int, and optional int has get as int method. For example, here just call get as int. Okay, and notice here get as int method returns a primitive type int. So just call this method. And finally, let us take the result into a local variable of type int and then say max. Next, let us put the system.println statement and just print the max, and let us run the program. And here you can see the output maximum number 10. Okay, so 10 is basically a maximum number you can see in the list. Next, here we can also simplify this logic. For example, here instead of storing the result of this stream method into separate stream object, so we can simply copy this and just remove this stream and paste it over here, and then call this map to int method on a stream and just remove this line of code. Okay, next, so here we have used the lambda expression to just call this int value method, right? So instead of using this lambda expression, we can use a method references. For example, here just remove this lambda expression and then call integer wrapper class. It has a method that is int value. Next, if you run the program, you can see the result 10. Next, let us see how to find the minimum number in a list using Javaguides stream. Well, the logic should be same, just we need to change the method from max to min. For example, here let me copy this and let me paste it over here, and here just change this max method. So instead of max, just call min method, and here let us change the local variable name from max to min, and here just pass min. That's it. Next, let's run the program, and here you can see the output. 10 is the maximum number, 1 is the minimum number. And again, if you modify the list with some different numbers, and here now you can see 90 is the maximum number in the list, and if we run the program, you can see 90 is the maximum number and 1 is the minimum number. So instead of 1, if I go here 10, now you can see 2 is the minimum number, right? So if I run the program again, you can see 2 is the minimum number, 90 is the maximum number. Alright, so this is the logic to find the maximum and minimum number in a list using Javaguides stream. Well, there are different ways to find the maximum number and minimum number in a list using Javaguides stream, but this is the simplest way to find the maximum and minimum numbers. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us discuss how to find the second largest number in a list of integers using Javaguides stream. Well, here is a given list of integers. Next, we need to find the second largest number in the list of integers. And if you can closely observe the list elements over here, so 75 is the first largest number, and then 65 is the second largest number. Okay. Next, let us go ahead and let us see how to use Javaguides stream to find the second largest number in the list. So first of all, we need to convert the list into stream. Okay, then only we can use the stream related methods, isn't it? So in order to convert list into stream, we can use stream method. For example, list has a stream method, and notice here this stream method returns a stream of integers. So just call this stream method over here. Next, stream has a distinct method. So let us call distinct method to remove the duplicates from the stream. And notice here again, distinct method returns a stream. So basically this distinct method is an intermediate operation and it returns a new stream which contains no duplicate elements. Okay, just call this distinct method to remove the duplicates. Next, just call the sorted method. Well, basically we'll sort the stream in reverse order so that we can easily get the second largest number. For instance, just call this sorted method which takes comparator as a parameter. Next, let us pass the comparator and then call its reverse order method. So this will sort the stream in a reverse order. For example, after sorting the stream, you can see the elements 75 comes first, followed by 65 and then 50 and then 35 and then 20 and then 10. Okay, so after calling this sorted method, the elements are sorted in a descending order. 75 comes first, 65 comes second and so on. Okay, next what we need to do is we need to skip this first element so that we can get the second largest number, that is 65. So in order to skip this first element from the stream, we can use skip method. For example, here just call skip method over here and we need to skip the first element. For that, let us pass 1. So this will skip the first element from the stream. Next, skip method returns stream and we can also call the methods over here. Let us say find first. So after skipping 75, we need to get the first element by using this find first method. Next, this find first method returns optional, so we can call get method to get the element from the optional. So here just call get method. Perfect. Next, let us take the result of this get method into a local variable of type int over here. Int second largest. Perfect. Next, let's put the system.out.println statement and just print the second largest variable. Next, let us run the program and you can see the output 65. And if you can notice the elements in the list, 65 is the second largest number and that is what printed over here. Okay, so this is how we can use Javaguides stream methods to find the largest, second largest number in the list. Alright, it is pretty simple. We first need to convert the list into stream. Next, once we got the stream, we can call its methods, right? Next, we can call the distinct method to remove duplicates. Next, once we sort the stream into descending order, 75 comes first and then 65 comes second and so on, right? In order to get the second largest number, we have to skip the first element. For that, we have used skip method. Next, skip method returns stream and we have again called find first method to get this 65 element. And then find first returns optional and we have called get method on this optional to get the second largest number as an integer. And that is what printed over here. Okay, it's pretty simple. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us discuss how to find the sum of all digits of a number using Javaguides stream. Well, here is a given input number and we need to find the sum of all these digits of a number using Javaguides stream. Well, there are total 5 digits and the sum of all these digits is 15. Well, notice here the input type int. So we can't convert this int into stream directly. We first need to convert this integer into string and then we can convert string into stream. Okay, so here just call string, it has value of method to convert integer into string and then pass this input. Next, this value of method returns string and we can call chars method. And notice here chars method returns int stream. So just call this chars method and take the result into local variable of type int stream over here and just call it as stream. Now we have converted integer into string by using value of method and next we have converted string into stream by using chars method. Okay, now we have a stream object so we can call its methods. Alright, and again notice here this int stream represents the ASCII value of each corresponding character in the stream. Okay, next what we need to do is we need to convert each ASCII value into its numeric value. For that we can use map method. So here just call stream object, it has a map method. So let us use map method to convert the ASCII value into its corresponding numerical value. And again notice here map method takes int unary operator as a functional interface, and we have to use the lambda expression to implement this int unary operator interface. So just call this method. Next, let us pass the lambda expression that implements int unary operator interface. So here just pass single parameter to the lambda expression followed by a lambda symbol, and within a lambda body just convert the ASCII value into a corresponding numerical value. For that, call character class. It has get numerical value method and just pass the character. Okay, perfect. So this map method will basically convert the ASCII value into corresponding numeric value. Next, call the sum method over here. Dot sum. Perfect. Next, let us take the result into a local variable of type int, and let's call it as sum. And finally put the system.out.println statement and then print sum. Okay. Next, let us run the program. You can see the output 15. Okay. Next, let us simplify this logic even further. So here, instead of storing the result of chars into a separate local variable of type int stream, just remove this and just call this map method here. Okay. Next, remove these two lines of code, and here let us introduce a local variable of type int over here. Next, here we have a lambda expression that just call this get numeric value method of character class. So we can replace this lambda expression with method reference over here. So just replace this lambda expression with a method reference. So character followed by double colon and then call get numeric value method. That's it. Next, let's run the program, and you can see the output 15. So this is how we can find the sum of all digits of a number using Java 8 stream. Even we can simplify this further, like here we can remove this local variable declaration, just put the system.out.println statement and then pass this statement over here. Next, remove this system.out.println statement. That's it. In a single line of code we have done the job. Next, let's run the program, and here you can see the output 15. Okay, so this is how we can use Java 8 stream to find the sum of all digits of a number. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us discuss how to print the even numbers from a list using Java 8 stream. Well, here is a given list of integers, and we need to print only the even numbers from this list using Java 8 stream. Okay, so let us see how to do it. So first of all, we need to convert the list into stream. Then only you can able to use stream related methods, isn't it? So here just call list. It has a stream method, and notice a stream method returns a stream of integers. So just call this stream method to convert a list into stream. Next, in order to filter the even numbers from the stream, we can call the filter method over here. So just call the filter method, and notice a filter method takes predicate interface as a parameter, and we have to use the lambda expression to implement this predicate interface. So basically, predicate is a functional interface that accepts a single parameter and evaluates the condition and returns the boolean value either true or false. Okay, so let us go ahead and call this filter method and provide the lambda expression to implement this predicate functional interface. So here let us pass the lambda expression that implements predicate functional interface. So this is the lambda syntax. Okay, next let us pass a single parameter to this lambda expression. Let us say num. Num stands for basically a number. Next, within a lambda body, just have a return keyword and then followed by the logic. So this is the logic to find the even number, right? Num modulo 2 equal to 0. If the number is divided by 2 and the remainder is 0, then the number is even number. Next, put the semicolon over here. Next, notice here the lambda body contains a single statement. So we can remove open and close curly braces as well as the return keyword from here. Okay, so just remove open and close curly braces as well as the return keyword from here, because the Java compiler will automatically determine the return type of the result. So just remove open and close curly braces. Next, the lambda expression has a single parameter. We can also remove open and close parenthesis over here. Okay, perfect. Next, after filtering the even numbers, we need to print each even number to the console. For that, what we can do is we can call for each method. And again notice here, for each method takes consumer functional interface as a parameter, and we have to use lambda expression to implement this consumer functional interface. So just call this method, and then let us have a lambda expression syntax over here. This consumer functional interface takes single argument and does not return anything. So here just pass num, and within a lambda body just put the system.out.println statement and just print this num. Okay. Next, the lambda expression body contains single statement. So let us remove the open and close curly braces from here. Alright. Next, let us run the program and let us see the output. And here you can see the output 2, 4, 6, 8, 10. So these are the even numbers. Alright. So this is the simple logic to print the even numbers from a given list using Javaguides stream. Okay. It's pretty simple. We first need to convert the list into stream, and then we need to call the filter method to add the condition like find even numbers. Next, we call for each method to print each even number to the console. That's it. And then we ran the program and we have seen that the even numbers are printed in a console. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us discuss how to remove the duplicate elements from a list using Javaguides stream. Well, here is a given list of integers and we need to remove the duplicate elements from this list of integers. Next, here is one more given a list of strings, and we need to remove the duplicate elements from this list of strings. Okay, so let us see how to do it. So let us first see how to remove the duplicate elements from this list of integers. Well, first of all, we need to convert this list into stream by using stream method. So here just call the list, that is numbers. It has a stream method to convert list into stream, and then stream has a distinct method to remove the duplicates. Well, again notice here distinct method returns a stream. Okay, so whenever you want to remove the duplicate elements, you have to use the distinct method. So just call this distinct method to remove the duplicate elements from the stream. Next, we need to collect the elements of the stream back into list. For that, let us use toList method over here. Alright, so notice here toList method returns a list of integers. Okay, perfect. Next, let us take the result into a local variable of type list and then pass integer as a type, and let us give name as list. Next, just put the system.out.println statement and just print the list. Next, let us run the program, and you can see the output 1, 2, 3, 4, 5. And if you can see the list elements, so there are duplicate elements in the list. Now you can see in the output there is no duplicate elements. So this is how we can use a distinct method to remove the duplicates. It's pretty simple. So what we have done, basically we have converted the list into stream first, and then we have called a distinct method to remove duplicates. Next, we have used toList method to convert again the stream into list. That's it. It's pretty simple, isn't it? Next, let us go ahead and let us see how to remove the duplicate strings from the given list of strings. So the logic is same. So here just call fruits is the list, and we need to convert this list into stream by using stream method. Next, stream has a distinct method, so just call the distinct method to remove the duplicates, and then finally call the toList method to convert a stream of elements back into list. Next, here let us take the result into a local variable of type list and then pass string as a type, and let us give the name as list2. And finally, let's put the system.out.println statement and just print list2. Next, let us run the program over here, and you can see apple, orange, banana. And if you can notice the input, you can see there are two apple elements in the list. Okay, two duplicate elements, right? and in the output you can see only one apple is present. So this is how we can remove the duplicate strings from the list of strings by using Javaguides stream. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us see how to write a Java program to reverse each word of a string using Javaguides stream. Well, here is a given input string and we need to reverse each word of this given input string using Javaguides stream. Okay. Well, first we're gonna split this string into words and we'll store it in an array of strings, and then we'll convert that array of strings into stream. Okay. So here just call input and then call split method and then pass space. We're gonna split the given input string by space. So this split method returns string of array. So here string of array, let us give variable name as str array. Perfect. Now we have string array. Next let us convert this string array into stream. So here just call stream. It has op method, and notice here op method takes array, so just call op method and then pass this string array. Next this op method returns stream, so here just have a local variable of type stream and then pass type string and let us call it as stream. Now we got a stream of words. Next let us reverse each word in a stream. So here just call stream object. It has a map method, so let us use map method to reverse each word. And again notice here map method takes function as a parameter and we have to use lambda expression to implement this function interface. So here just choose map method and just pass the lambda expression. So this is the lambda expression syntax. Okay. Next function interface takes single parameter. So let us pass single parameter to the lambda expression. So just say word. Okay. Next go to the lambda body. Within a lambda body let us write the logic to reverse the word. So we can use string builder provided reverse method to reverse the word. So here just type new. Before that let's have a return keyword and then new string builder and then pass word as a parameter to the string builder constructor, and then it has a reverse method. Okay. And again we need to convert string builder into string. So here just call toString method. Perfect. Next, if you can notice here, the lambda body contains single statement, so we can remove the open and close curly braces as well as the return keyword from here. So just remove open and close curly braces over here. Okay, so this is the lambda expression to reverse the word. Next, after reversing each word, let us call the collect method to collect the result. So just call collect method and then pass collectors utility class. It has a joining method. So we need to join each reverse word by space, right? For that let's call joining method and just give the space. Next let us hold the result of this statement into a string and let us call it as result. And finally let's put the system.println statement and just print the result. Perfect. Next let's run the program and here you can see the output. Each word is reversed in the given input string. Okay. Next let us refactor this code and reduce some lines of code. So here we have assigned the result of split method into a separate variable. So instead of that we can simply pass this logic here, and next we can remove this line of code. Okay. Next here also the result of this op method we have assigned to a separate variable of type stream. So instead of doing that we can remove this. Okay, and this op method returns stream, so we can simply replace this stream. That's it. Next this op method returns stream, so we can change the method calls like here. So let me align this code properly. Okay, so this is how we can refactor the code. Now in a single line of code we have written the logic. Next let us run the program and you can see the output. Okay, so this is how we can use Javaguides stream to reverse each word of a given input string. Alright, great. I will see you in the next lecture. Let us write a Java program to sort a list of strings in ascending and descending order using Javaguides stream. Well, here is a given input list of strings. Next, we need to sort this list of strings in ascending and descending order using Javaguides stream. Alright, so let us see how to do it. So first of all, we need to convert this list into stream. Then only we can use the stream related methods, right? So here just call the list, that is fruits, and it has a stream method. So this stream method create a stream from this list. So just call this stream method. Next, in order to sort the stream elements, stream provides a sorted method. Well, notice here there are two overloaded sorted methods. And first we're gonna see how to sort the list of strings in an ascending order. For that, let us use this sorted method. It does not take any input arguments. So just call the sorted method over here. So this sorted method basically sorts the elements in a natural order, that is in alphabetical. Well, if the input is a list of strings, then this sorted method will sort the list of strings in a alphabetical order. If the input is a list of integers, then this method will sort the list of integers in a ascending order, that is in a numerical order. Next, after sorting the stream, we need to convert the stream of elements back into list. For that, let us call toList method. Next, let us take the result into a list of type string, and here let us give the variable name result. Next, let's put the system.out.println statement and then print the result. Next, let us run the program, and here you can see the output. The list of strings are successfully sorted in ascending order: apple, banana, grapes, mango. Okay, so if you can see the letter A comes first, followed by B, and then G, and then M. It means the elements are basically sorted in ascending order or alphabetical order. Okay. Next, let us go ahead and let us see how to sort the list of strings in a descending order. So here, first of all, let me comment out this. Okay, so here first let us convert list into stream by using stream method. So here just call the list, that is fruits. It has a stream method. So this stream method basically create a new stream from this list, and then stream has a sorted method. So here basically we are going to sort the list of strings in a descending order. And in order to sort the list of strings in a descending order, we have to pass the comparator to the sorted method, right? So here just call the sorted method that takes comparator as a parameter. And here just pass the comparator dot reverse order. So this reverse order method will sort the stream of elements in a descending order. Okay. Next, we need to collect the result back to the list. For that, just call toList method. Next, here let us take the result into local variable of type list and then pass type string, and let us call it as result. And finally, let's put the system.out.println statement and then print the result. Next, let us run the program, and here you can see the output. The list of strings are sorted in a descending order. You can see the letter M comes first and followed by G, B, and A. This is the descending order, isn't it? So this is how we can use Javaguides stream to sort the list of strings in a ascending order as well as descending order. Okay, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into how to sort a user by age in ascending order and descending order. So basically, we are going to use a sorted method along with a comparator to sort the user by age in ascending order and descending order. Okay, so let us go to our project and let us create an example. So here, go to the sorted package, right click on it, new, and then choose Java class. Let us give class name as sort user example. Next, within this class, let's create a main method. Well, in order to sort the user by age, we need to first create a user class, right? So here just type class and then user. Next, let us define the instance variables within this user class. So just type private and then string name and then private int age. To keep it simple, let us have these two fields. Next, right click on this user class, generate, and then choose getter and setter, and then choose these two fields, click on OK. Next, let us also create a constructor. So here, right click, generate, constructor, select these two fields, click on OK. Perfect. Next, also create a toString method. So go at the end of this class right click, generate to string, select all these fields, click on OK. Perfect. Now the user class is ready. Next, go to our main public class, go to main method. Within this main method, let's create a list of users. So here just type list and then pass user as a type, and let's give reference variable name as users, and then arrays. Arrays is a utility class. It has as list method to create a list. So within this as list method, just pass the user objects. So here new user, and then pass username as Ramesh. Let's give age as 30. Next, let us create few more user objects. New user, and then pass name as Umesh. Let's give age as 28. Next, new user, let's give username as Sanjay, and then let's give age as 35. The age should be in a integer, and then new user, let's give username as Pramod, age 32, and then new user, let's give the username as Meena, and let's give age as 25. Now we have a list of users. Next, let us go ahead and let us see how to use stream provided sorted method to sort a list of users by age in ascending and descending order. So here first of all we need to convert this list into stream, right? So here just call this list, that is users. It has a stream method. So this stream method basically create a stream by this list, and stream method returns a stream, so we can call the sorted method on that stream. So here just type sorted, and notice here in order to sort the elements in a custom order, we have to use the sorted method that takes comparator as a parameter. So just call this sorted method, and here we need to pass the comparator as a parameter to this sorted method, right? So first what we're going to do is we're going to first implement the comparator here. So here just type comparator, and notice here comparator interface is a generic interface from java.util package. So just call the comparator and pass user as a type. Next, let us give reference variable name as user comparator, and then new comparator. So here basically we are using anonymous class to implement this comparator interface. Okay, next go to the compare method, and here we're gonna sort the user by age, right? So just call this object 1. It has get age method, and then minus object 2 dot get age. So this is the logic to sort the user by age in a ascending order. Okay, next put the semicolon at the end, and then finally let's pass this user comparator to the sorted method. So here user comparator. Next, this sorted method returns a new stream with the sorted elements, and we need to convert that new stream into list. For that we can use toList method. Next, let us take the result of this toList method into local variable of type list, and then pass the type as a user. Next, let us give the variable name as result, and finally put the system.println statement, and then pass result. Result is a user object. It has a toString method. Next, let us run the program, and you can see the output over here. So Meena has a age 25, Umesh has a age 28, Ramesh has a age 30, Pramod has a age 32, Sanjay has a age 35. And if you look at the numbers, 25, 28, 30, 32, 35. Okay, so basically the users are sorted by age in a ascending order. Okay, so this is how we can use sorted method with comparator to sort the user by age in a ascending order. Okay, and notice here we have used an anonymous class to implement this comparator interface. So instead of using anonymous class, we can use the lambda expression. For example, so just remove this user comparator from here and pass the lambda expression. So this comparator interface takes two parameters. So just pass two parameters to the lambda expression, that is object 1 comma object2 and then followed by lambda symbol, and within lambda body just pass this logic. Just copy it, paste it over here. That's it. And just comment out this. This is it. Okay. So by using lambda expression we can simplify a lot. Okay. Next, let us run the program and you can see the output over here. Same output. The users are sorted by age in a ascending order. Okay, perfect. Next, we can simplify this logic further. So instead of using lambda expression, we can use the ready-made logic provided by comparator. For instance, just remove this lambda expression and then call comparator. It has a comparing int method and then pass the age field to this comparing int method. For instance, just call user and then method reference and then call get age. That's it. So this comparing int method internally provides a logic to sort the user by age in an ascending order. For instance, let us run the program over here and you can see the result. Same. Okay. The users are sorted by age in an ascending order. You can see age 25, 28, 30, 32, 35. Okay. Perfect. So instead of writing the code manually, we can use the existing code like this. Alright, perfect. So this logic is to sort the user by age in ascending order. Next, let us see how to sort a user by age in a reverse order or in a descending order. Descending order. It's pretty simple. Just copy this code and paste it over here. As we know that this code will sort user by age in a ascending order, right? So in order to sort the user by age in a descending order, what we need to do is we need to just call the reversed method. For instance, go to this sorted method, go to the comparator and then comparing int. So this comparing int method returns a comparator and comparator has a reversed method. So here just call the reversed method. That's it. So this logic will sort user by age in a descending order. Okay. So let us give different variable name. Let us say result1 and here also result1. Okay, perfect. Next, let us run the program over here and you can see the output. The users are sorted by age in a descending order. You can see the numbers 35, 32, 30, 28, 25. Okay, so this is how we can use a sorted method with the comparator to sort the user by age in a descending order. It's pretty simple, right? Next, let us say we have a requirement like sort the user by name in a ascending and descending order. Then how we can do that? So here let me show you how we can sort the user by name in a ascending and descending order. It's pretty simple. We just have to use the comparator provided methods. For instance, here let me copy this code and here let me paste it and here let me change accordingly. Sort the user by name in ascending order and here let me name it as result2 and here instead of using comparing int method we have to call the comparing method and then pass the field that we are going to use for comparing. In this case the field name is name. Okay, so just call user and then method reference and then call get name. That's it. Next, here just pass result2. So this logic will sort the user by name in a ascending order. Next, let us run the program and let us see the output. So here let me run the program and if you can notice the output over here, the users are sorted by name in a ascending order. You can see first letter of a name M and then P and then R S U. Okay, perfect. Next, let us see how to sort a user by name in a descending order. It's pretty simple. We just have to call this reversed method, right? So here let me copy this piece of code and just paste it over here and let us change accordingly. Sort the user by name in a descending order and here let us give the variable name as result3 and here just call the reversed method. A reversed method basically returns a comparator that provides a logic to reverse the user by name. just call this method, and here just pass result 3. That's it. Next, let us run the program, and here you can see the output. The users are sorted by name in descending order. You can see first letter of a name, U, S, R, P, M. Okay, perfect. So this is how we can use sorted method to sort the user by name in ascending and descending order. Okay, perfect. I will see you in the next lecture. Hi everyone, welcome back. In this video, we will discuss one of the important interview questions on Java 8 streams. Well, here is the problem statement. You have a list of employees and you need to group the list of employees by age using Java 8 streams. Okay, so basically you have a list of employees and you need to group the list of employees by their age using Java 8 stream. Well, Java Stream API provides collectors.grouping by method to group the elements based on certain attributes. Well, this grouping by method basically works like a group by clause in a SQL statement. Okay, so let us go ahead and let us see how to use this collectors.grouping by method to group the list of employees by their age. Let us go to our project in IntelliJ IDEA, and here let's create a new class. Let us give class name as group employees by age. Next, within this class, let's create a main method. Well, here we are going to group the employees by age, so let us create a employee class. So just type class and then give class name employee. Within employee class, let us define the instance variables. So here private int id and then private string name and then private int age. To keep it simple, let us have these three instance variables. Next, let us create a constructor. Right click, generate, choose constructor, select all these fields, click on OK. Next, create a getter methods to get values of these instance variables. So here right click, generate and choose getter, select all these fields, click on OK. Perfect. Next, let us also create a toString method over here. So right click, generate toString, select all these fields, click on OK. Perfect. Now our employee class is ready. Next, go to the main method. Within the main method, let's create a list of employees. So here just type list and then pass employee and then give name as employees, and here let us use arrays.asList method to add object to the list, and here just pass the employee objects. So new employee and then pass id as a 1, employee name let us give Ramesh, and then age 30. Next, let us add a few more employee objects. Perfect. Now we have a list of employees. Next, let us see how to group the employees by age. So here first we need to convert this list into stream. So here let us call the list, that is employees. It has a stream method. So we use stream method to create a stream from this list. So just call this stream method. Next, this stream method basically returns a stream object that contains these employee objects. Okay, so here just call collect method on the stream object, and notice your collect method expect the collectors utility class, and this collectors utility class basically implements the collector interface. Okay, just call this collect method over here and then pass collectors utility class. Make sure that you import collectors utility class from java.util.stream package. Next, this collectors utility class has a grouping by method. Well, grouping by method works similar to group by clause in SQL statements, and if you can notice here, there are three overloaded grouping by methods, and we have to use based on our requirement. For example, in our example, we are going to group the employees by age, so we have to pass the age as a field to this grouping by method, and this grouping by method basically returns a map. It contains key value pairs, and the key is basically a field name and the value is basically a list of employees. Okay, so here just call this grouping by method. Next, let us pass a lambda expression that implements this function interface. So here just pass employee as a parameter to the lambda expression followed by lambda symbol, and within a lambda body just get the field name, that is age. So for that just call employee object and then get age. Well, this grouping by method takes age field and it group the list type employees by using this age field. And grouping by method returns a map. It contains age as a key and the list type employees of the same age as a value. Okay. Next, this grouping by method returns a map. So here let us introduce a local variable of type map over here and then pass integer as a key type. Well, here basically the key is age. So age is a type of integer. So just pass here integer as a type of key, and value basically is a list of employees. So here just pass the type list and then employee. Next let us give the variable name map. Okay. Next let us iterate over this map and print age and corresponding list of employees. So here map, it has for each method and then pass key value pair to the lambda expression. So here just key comma value and then lambda symbol. Within a lambda body just put the system.println statement and print the key. So here key is nothing but age. So here let me add the string. Next here value is nothing but a list of employees. Okay. So here put one more system.println statement and then here list of employees and then pass value. Next let us run the program over here, and here you can see the output age and the corresponding list of employees. So here you can see the age 30. So there are two employees who has age 30, and here also there are two employees who has age 28, and here is only one employee that has age 35, and here is also one employee that has age 32. So here basically we have grouped a list of employees by their age. Okay. So this kind of questions you may get in a Java interviews. The key point here to remember is that the collectors.grouping by method. So this grouping by method works similar to group by clause in a SQL statement. And remember, this grouping by method returns a map. It contains key value pairs, and key is basically a field name and value is basically a list of elements. In this case the key is basically age and the value is list of employees of the same age. Okay. Perfect. I will see you in the next video.